All right, hi everyone. So today we're going to start on the introduction on functions, and first thing first, we want to understand. Before we understand what's function, let's understand what is the concept of a mapping. All right. So let's look at something that we are quite familiar with. So, for example, we have y equals to x plus 1. Now, we know that with different x value, we get different y values. So in this example, let's just say y equals x plus 1 and assume that x is 1. We know that y is 2. So I'm going to put that onto the graph. All right. And when x is 2, we know y is 3. So maybe somewhere around here. All right. We can probably connect it. Probably connect something like that. Yeah. And basically we form a linear function or a linear graph, right? Okay, so a mapping is a very similar concept to what we have just done. Now, the input value that I just given for x, 1 and 2, we consider them as inputs. And we'll put it into this oval diagram, 1, 2, all right? And the outcome, right, which is basically the y value, we call it the output. And in this example, of course, our output was 2 and 3 respectively. All right. So we will put an arrow to indicate that with that input, you get that particular output. All right. Now, so this is basically what we call a mapping diagram. Mapping diagram. Yeah. And how do we connect this concept? We will say that x is mapped, and we're going to write this funny notation, is mapped to x plus 1. All right, so this is written, I'll write out in English. It means x is mapped to x plus 1. Yeah, so in a very simple understanding, just know that input is your x value, all right, in this case. Your output is your y. All right, and one input in this case gets you only one specific output, right? When you sub 1 into the x, only 2 will appear for your y. There's no other possible outcome. Yeah, so in this specific example, just this specific example, we call this a 1-to-1 mapping. All right, so 1 input, 1 output. Okay, let me put here 1 input, 1 output. All right, so this is the, I would say, the beginning concept of functions. And we will look at more examples of different mappings. Okay, so let's look at the next part. All right, so I have here 3 types of mapping that will be done. All right, and I'll show you these 3 different types, and I'll explain to you what's going on. All right, first one. Our input is x, our output is x plus 1. It's basically what we have just done. So this is a linear line. Okay, now this kind of mapping we call it a 1-to-1 mapping, because one input results in one specific output. If I try another point, one input results in one specific output. All right, so basically one value of input results in one value of output. You can't have 2 values of output. Yeah? All right, next one, x and your output is x squared. I think you guys are quite familiar. This is a quadratic function. All right, maybe I just draw it very quickly like that. All right, so this is a quadratic function, or before you understand function, we call it a quadratic graph, right? Now, this is a bit unique because we will have actually, in this case, one specific input and another input which could result in the same output. For example, like you substitute x equals to 1, x squared will be equals to 1, or if you substitute x to be minus 1, x squared is also 1, right? So even though you have two different inputs, you still get one output. All right. Now this kind of mapping, we call it a many to one. Why many to one? Because you have many inputs but still result in one output. Notice that my input may be different but my output's the same, and that's the relationship, how that works. Yeah. Okay. Now the next type is a surd function. Now you may not have come through this, or we don't really call it a surd function, it's just a surd graph, right? It's not a function per se. So in case you don't know, it looks something like that. Now this is a bit unique, right? If you look at one input here, you see that you result in different outputs. One input resulting in two different outputs, one here, one here. Now this type of mapping, we call it a one-to-many. One-to-many. So one input giving you many outputs. Okay, so let's jump the gun a bit. Now in these three types of mapping, are they all functions? The answer is no. All right. First type, a one-to-one, this is a form of function. It is. And I will define to you what function is later on, yeah? Just be patient. Now, what about the many-to-one mapping? That is also a function. But the last example, when one input gives you many outputs, that is not a function. Right? So a function may not be just because it's a graph. There is a specific definition of what a function is, which we will have to definitely go through. Okay? So which leads me to my next part. Then what is defined as a function? We must be very clear with the definition so that we know, oh, something is a function or something is not a function. All right? So a function is defined, or is a rule that maps each x value to just one y value. Okay? And of course we have specific input values, and that x values just maps to only one y value. So which basically means that in the example type, okay, we talked about one-to-one being a function and many-to-one as a function, and that is specifically what a function is. A function can be either a one-to-one mapping, or we call it a one-to-one function, that is a function, or it can be a many-to-one function. That is also a function, just like a quadratic graph, right? Now, a one-to-many is not a function. A one-to-many is not a function. Okay, so in terms of function, how do we write it? Now, we write it in two different ways. Either we write it in the mapping format, or we write it in a function equation format. All right, but both means the same thing. Okay, let me just share with you. If it's a mapping format, we say therefore f x is mapped into or mapped onto x plus 1, given that x belongs to some real values. Now, don't worry about this part. I'll explain to you what this means. All right, and another way to write functions, we just say it as fx, all right, equals to x plus 1, where x belongs to real number. Again, this both means the same thing. All right, either way, they mean the same thing. All right. Okay, so then what is this part at the back? All right, this part at the back is basically what we call the domain. Domain is basically what are the inputs of x values. What are the inputs for x values? That means what x value do you want to put into the function to get you the corresponding y value. Okay, so that's the domain. Now, if you look at this example, we will use that to actually go through what you mean by domain and range. Now, we look at this linear function. you see that we have the coordinate -1, -3, and coordinate 3, 5. So that is basically a linear function, right? It's just a straight line graph. And we have those 2 points, and those 2 points are the end to end of the function. So in this case, the end to end, we will say that this end to end, the entire x value, we call this the domain. We call it domain. Now, on the other hand, how much height is going from the lowest point of the function to the highest point? We call this the range. We call this a range. So, how do we state then what is the domain and range of the linear function? We say that the domain, the domain is between -1 to 3, right? -1 to 3. So we say x is between -1 to 3. All right, so that's a domain. Now, the range is how high from the lowest point to the highest point of the function. So the range in this case, we say that it is from the lowest point, which is -3, up to the highest point, which is 5. So we say the function has a range between -3 to 5. Okay, so this is the format on how you will write your domain and your range. All right, so take note of that. We don't really write y in this case. We write fx or gx as your y for the range. Now, let's look at the second example of a quadratic function. Now, you might have noticed that I have specifically put this in the vertex form. All right, and since this is a minimum parabola, we know that the vertex in this case is 2, 3. So I'm going to map out 2, 3 right here. All right, and basically our graph will go from here to here, where it cuts a y-intercept, and then it just goes up, right? Okay, so where is the ending point and where is the starting point? So let's talk about when x is 0. If you look at this part of the function, it's given you the domain. All right? So in this case, the domain, we can rewrite this, is as given. So the domain is between 0 to 6. That means this endpoint here must be 6. Okay? Now, then what is the starting y-intercept? That is when x is 0, if you were to do it quickly mentally. 0 minus 2 whole square will be 4. 4 plus 3 is 7. So at 0, your y value is 7, or in this case, your fx is 7. Okay, so domain is nothing too difficult to understand, but problem is, what is the range? Is it from 7 to something? What is it? Now, if you look at the quick sketch, you know that the highest point in this case will be when x is 6. All right, so that coordinate, if you were to work it out, when x is 6, your fx is 19. So you may think that, oh, okay, my range is therefore 7 to 19. Unfortunately, that's not true. The range has to start from the lowest possible point of your function, and the lowest point is not at 7. In fact, your lowest point is at the vertex itself, which is at 2, 3. So therefore, we say the range of this function is from the bottom part, which is 3 for the y, and the highest part, which is 19. Okay, so the range, we will therefore say that fx is between 3, which is the lowest point, and 19. Okay, so that is basically how we state the range and domain of different functions. All right, I hope this explanation has been clear on the definition of functions, the notation, what we mean by domain and range of a function, as well as we look into mappings, the different type of mapping, and what constitute a function and what does not. All right, so remember, a function has to be either one-to-one or many-to-one. A one-to-many mapping is not a function, because function is defined by the fact that every x value just has one specific y value. It cannot have 2, it cannot have 3, it cannot have 4 y values. All right, so I hope this is clear. I hope you understand today's lesson on functions, and I hope to see you on the next one. Cheers.